Hey, so this class we're going to work on rationalizing denominators. So this is pretty simple. All we have to do is get rid of the square root sign in the denominator. This can be a square root, a cube root, it can be any type of root, but we just need to get rid of that. So what we need to know first is that multiplying any number by 1 gives us the exact same answer, which is kind of pretty obvious. But now you might ask, how can we use that fact to get rid of the square root sign? We can multiply this fraction by root 8 over root 8. Basically, all we did was that we multiplied by whatever's in the denominator to get rid of the square root, because we know that root 8 squared is just 8. So we need to use that fact to get rid of the square root sign. And since root 8 over root 8 is equal to 1, we're not changing this number. It's still the exact same number. We're not actually doing anything to it, but changing how it looks. So yeah, this will give us, so root 8 times 4 is 4 root 8 plus 2 root 24 over 8. Now we can simplify a bit, so this will give us root 8 times 2 plus root 24 over 4. And we're done, because now we got rid of the square root in the denominator, and we don't have to really do anything else. So yeah, that's the first question. Okay, moving on to the next question. This is a bit harder because this time we can't really multiply both sides by root 2, because this will give us a root 2 with the 1, because 1 times root 2 is root 2, so we wouldn't really get rid of that. So there's a nice trick in math called the conjugate. I'm going to write it here. Conjugate. Basically what this means is that we have to multiply the denominator by itself with the sign flipped. So we would multiply 1 minus root 2 times 1 plus root 2. This would get rid of all the roots, because we know that x plus y times x minus y is equal to x squared minus y squared. So we're basically using this fact to square both the x and the y and get rid of the root. So yeah, let's actually do that now. So what we can do, multiply this by 1 plus root 2 on the top and the bottom. Once again, what we're doing here is that we're multiplying by 1 because we don't want to change the original question, so this works. But yeah, this is easy now. 3 times 1 is 3. 3 times root 2 is 3 root 2 over, we already know once again that x plus y times x minus y is equal to x squared minus y squared. So let's use that fact. 1 times 1 is 1. Root 2 times root 2 is 2. So minus 2. Basically, we squared the x and we squared the y. X, y. But yeah, that's pretty simple. And we're almost done. We can simplify a tiny bit. But yeah, this would give us 3 plus 3 root 2 over negative 1. Which is also equal to negative 3 plus 3 root 2 or negative 3 minus 3 root 2. And we are done. Okay, so the third question, this is one of the easy ones again because we only have one term in the denominator. But yeah, the way you could do that is the exact same thing. Multiply the top and bottom by root 4. So you might ask, why did we not multiply by 5 root 4? It's because the 5 is already a whole number, so it won't matter a lot. You could do it if you wanted to, but it won't really do much, and you're just making the numbers bigger for no reason. But yeah, it still would work. You can do it if you get confused. But yeah, we can also do this, so that's what I'm doing. But yeah, so 4 times root 4 is 4 root 4, plus 2 root 3 times root 4 is 2 times root 12 over, and then 5 times root 4, 5 root 4 times root 4 is 5 root 16. But yeah, now you might ask, hold on, root 4 and root 16 are whole numbers, and this was kind of like a trick in the original question. Root 4 is 2. So what this tells us is that sometimes you just have to look at the question before even trying to do what we want to do, because if I knew this was 2 from the beginning, I would have said 5 times 2 is 10, and then the original answer would have been 4 plus 2 root 3 over 10, and we would have been done because we rationalized the denominator. But yeah, now I'm going to try to prove that this gives us the exact same answer. But yeah, so 4 root 4 is 4 times 2, which is 8, plus 2 root 12 over 5 root 16 is 5 times 4, which is 20. Now we can divide everything by 2. This will give us 4 plus root 12 over 10. Now you might ask, these don't look similar, but there's another trick that you might know how to do. You don't really need to know this for now, but root 12 is root of 4 times 3 over 10. So what we know is that this will give us 4 plus 2 root 3 over 10, because root of 4 is 2, and we already know that. But yeah, so these are the exact same. But yeah, this question kind of shows us how sometimes you just gotta look at the question before actually trying to do anything to it, because the answer might be right there. But yeah, so that's it for this question. Okay, question number 4. This time we cannot do anything to the question before starting it. So what we gotta do is multiply the top and bottom by root 2 plus 2. And the numerator and the denominator, once again, this is equal to 1, so we're not changing the question. But yeah, this will give us 4 times root 2 is 4 root 2. 4 times 2 is 8. And then all over this squared minus this squared, once again, kind of memorize this rule. X plus y times x minus y is equal to xy minus y squared. This is called the difference of squares. But yeah, so root 2 squared is 2. 2 squared is 4, and then put the negative sign between them. That's it. Now this would actually give us 4 root 2 plus 8 all over negative 2. We can divide the numerator and denominator by 2. So this will give us 2 root 2 plus 4 over negative 1. And then dividing anything by negative 1 just flips the sign. So this will give us negative 2 root 2 minus 4. And we are done. Okay, question number 5. This is kind of the exact same as the previous question, but once again, let's multiply the numerator and denominator by root 3 plus 1 and root 3 plus 1. So once again, it's 1, so we're not changing anything in the question. This will give us 3 times root 3 is 3 root 3, and then 3 times 1 is 3, and then 3 times root 3 is 3 again, and then root 3 times 1 is root 3. What I did here was root 3 times 3, 3 times 1, and then root 3 times root 3, and then root 3 times 1. FOIL. Basically expand both multiplication terms together. And then this would be over, let me do this in white actually. Yeah, this would be over this squared minus this squared. So root 3 squared is 3 minus, and then 1 squared is 1. Now this will give us 3 root 3. We know that this is equal to 6. 3 plus 3 is 6. And we also know that actually root 3 plus 3 root 3 is 4 root 3. So let's also change that. I can change this to 4 root 3 plus 6. And then 3 minus 1 is 2. Let's divide everything by 2 again. So 2 root 3 plus 3. And we are done. So last question. This one is a tiny bit harder than the rest because there are variables and no numbers. But we're going to do the exact same thing. So we're going to multiply this fraction by root a minus root b over root a minus root b. Pretty simple from here. We could just have to multiply everything out. So root a times a is equal to a root a. And then a times root b is a root b. But we need a negative sign because the root b has a negative. Next, we have root ab times root a. This will give us plus root of a squared b. And then finally, we have root ab times root b. So this will give us root ab squared. And then all this is over this squared minus this squared. So this will give us a minus b. Now you might ask, we're done because there's nothing to simplify, but you'll be wrong because we can notice that we have a squared here and b squared here. So let's take that out of the root. This will give us a root a minus a root b. And then square root of a squared is just a. So plus a root b. And then for this one, square root of b squared is b. So minus b root a. Now we notice that we have a few more like terms. First off, these two can go away. Actually, let me write the denominator first. So yeah, all this is over a minus b. But yeah, so we notice that these two can go away because negative root b times a plus root b times a is 0. So all this goes to 0, and then we have two more terms. So this will give us, let me write it in white. Yeah, so a root a minus b root a over a minus b. Now we can notice that we can factor out the root a on top because it is on both terms. So factor out root a, and then this will give us a minus b inside the bracket, and then a minus b on the bottom as well. And then after that, we notice that these two are the same. So what we could do is just simplify both, like that, and we get a final answer of root a. And this question is pretty neat because if you plug any number in the calculator, let's say you decide a is equal to 3 and b is equal to 4. If you plug in this in the calculator and you plug in this, you're going to get the same answer. And that's pretty neat. Basically, we know that b does not matter at all. So if no matter what b is, if a is 3, the answer is going to be root 3. That's pretty much it. So we're done.